This video will be a follow-up to us programming the quadratic formula into our TI Nspire. I just thought of another example that might be helpful to see as well, and give us a chance to see how this define command works in the Nspire in another way. So if I jump into my Nspire here and type the command define again, I'm going to create another program. This one I'm going to call the Vertex program. And I'm going to say that the Vertex program also requires the A, B, and C variables, or parameters as you might want to call it. I'm going to say that the Vertex is equal to, now I'm going to jump into this menu here to create two results. I'm using this key here to get us these different brackets and symbols, and I'm going to use this one. And I'm only choosing this because currently I'm unaware of a way to produce a coordinate as a result. So I'm going to use this brace to generate two different results, two different calculations, if you will, for a vertex. I would like to establish the x-coordinate and the y-coordinate for this vertex and place them in these two rows. Now, if you recall, the x-coordinate of a vertex of a parabola is going to be located at the opposite of b divided by 2 times a. So again, I'm entering the formula, if you will, based on the parameters a and b. And then below, now this one gets kind of tricky here. If you think down below, the y-coordinate would be essentially our quadratic expression. So a times x squared plus b times x plus c, but we haven't defined x in this problem. But as it turns out, the x value that we're going to use in the y calculation, the calculation of the variable y, well, the x value here is precisely the x value that we computed just a moment before. So if I copy this x and delete this one, let's see what happens here. Start a set of parentheses and put inside of it this formula. So this formula is what calculated the x value, and now we're going to take a times that x value and square it. We'll do the same thing over here with this b value. I'll delete the x, and inside of it place the opposite of b divided by 2a. And I think this expression looks pretty good. Now, it's important that we do use multiplication signs here in between the parentheses, otherwise the Nspire might have trouble establishing that command, that multiplication. Also, it's worth noting that I'm using my computer here, so copying and pasting works really easily. Control-C, Control-V works. But it also works on the handheld, so you can use that shortcut there as well. So I'm going to tap Enter, and I see that the Vertex command has been written. And I'm going to provide the three numbers again. So we're going to use the same quadratic formula, or the quadratic function from earlier, with an a value of 1, a b value of -6, and a c value of 8. And so this now tells me that, and it doesn't look like a true coordinate, but it's acting like one. This is exactly what I wanted to see. It looks like our vertex for a parabola that's defined with the function 1x squared minus 6x plus 8. The location of that vertex is here at 3, -1. And if we take a look at our picture of the graph, it appears to be correct as well. 3 to the right, 1 down from the origin. That's our vertex. So again, with the program already saved here, I don't have to define it ever again. I'm just going to jump up and save. Let's see here, we want File and choose Save. I'm going to save this document so the next time I call it, the Vertex command is also built in there. And now if I need to find the vertex of that really strange function, the one that didn't have any real number answers for the quadratic formula, it should have real number answers for the vertex. So let's see what the program tells us here. Alright, so we've got a result, again in decimal form. Due to the repetitive nature of these decimals, I think they can be converted back into fractions. And there might be a faster way to do this, but I don't recall off the top of my head. Maybe we can research this at another time. But I found a tool that will convert that. If we jump into the library button here, I did some searching and found it a second ago, so it's active on my screen right now. There's a command called approximate fraction. and that's in the general library. We might be able to find its shortcut elsewhere, but I'm just going to double click that. And I'm not going to type anything else because it's going to take the prior answer and try to turn that into a fraction. So if I tap enter, we've now changed the decimal result that we got a minute ago and have now turned it into a fraction. It's easy to go from fractions to decimals, but a little bit more difficult to go from decimals back into fractions. But I think it worked out here. So again, with a little bit of practice, you'll become familiar with and comfortable with using these command structures and building these commands or formulas in the calculator, and that may save you some time in the long run. Thanks for watching.